God's peace is yours, Algebra 2 students. This is mainly for Becca Ramsaran today, but you others you can look on as well. I trust you will be able to derive some kind of benefit from this, but God, you lead us and guide us so that this will be fruitful in Jesus' name, please. And here, this is going to be taken from your extra practice. That's the extra practice handout taken from the online text for chapter 2. Extra practice. This is actually chapter 3. Extra practice. All right. Ever done it like this before? Because right off the bat, I'm going to show you something which just doesn't look right. But anyway, using synthetic division to evaluate the polynomial for the given value, this should be negative 2x cubed. When you look at your extra practice number 27, that's what you see, plus 7x squared minus 3x minus 9. And we want to check out x equals negative 2 to see if it's a 0. And I think we did this one before. So I'd like you to just look as we do it again. Then you can do, well, you know what? Let's do this one together. And then you can go back and do this one for practice. Okay? Now, so here comes the synthetic division. We're going to evaluate it. So we have a vertical line here, horizontal like this, and then we write the coefficients of the polynomial, starting with the leading, which is 6. Then the next one is negative 7, because that's a 7x squared. And we don't have an x term, so we have got to put a 0 in for it. 0x, and then we end up with 10. And we want to evaluate it at 0.5, which is the same as 1/2. And notice when you have an x2 here, you put exactly what it says. You don't put the opposites. So it's a half or 0.5. Okay, so the first thing we do is we bring down the leading coefficient, and we do 1/2 times 6. Half of 6 is what? 3, right? We add this way, so this would be a negative 4. And then we multiply this way, which is a half of negative 4, which would be what? Negative 2. We add this way, it's going to be negative 2. And we multiply this way, a half of negative 2 would be negative 1. When we add this way, we get 10 minus 1 is 9. So the answer would be 9 for this one. Now you get the very same thing if you put 1/2 in for x, and you say 1/2 cubed, then multiply it by 6, minus 3 times 1/2 squared, multiply it by 7, and then add 10, you'd come out with 9. So that's what a really fast way of evaluating it, even faster than plugging it straight in here. Okay, so this is one for you to go back and do. Make sure you do it again and confirm that the answer we got in class is the same one you got. Now I decided to do one of these with you so you can do the others to practice. It says here determine whether the given binomial is a factor of the polynomial p of x. So here's the polynomial p of x. It's equal to 3x cubed plus 11x squared plus 2x minus 16. And this is going to be easy because if we do it by synthetic, in fact, we're going to check this binomial out, x plus 2. Not this one. This one is for the other one. This is for number 30. So we won't do this one. You will do that one. But let's check this one out. We're going to go and set up for synthetic. And if we get 0 for the remainder, it will mean that x plus 2 is a factor. If we get a number which is not 0 for the remainder, it will mean that x plus 2 is not a factor. So let's go ahead and write the coefficients starting with the leading one of 3. We have 3. Next comes what? 11. Then 2. Then negative 16. Since we're testing this x plus 2 to see if it's a factor, what we want to do is we want to use x equals what? X equals negative 2, because negative 2 would make the 0. So you have to be just watchful here and put your negative 2 over here. And now we get into the synthetic. Bring down the 3, multiply it by negative 2, we get a negative 6. Add, we get a positive 5. Multiply negative 2 by 5, we get a negative 10. We add, we get a negative 8. We multiply negative 2 by negative 8, and we get positive 16. You might say, you're positive about that? Yes, I am. And now, when we do negative 16 plus 16, we get 0. So, yes, we got a factor here. X plus 2 is a factor. Again, if we got a number which was different from 0 here, then we'll say it's not a factor. So you can do the others and get to your practice, all right? But you need your practice for your test or your quiz tomorrow. Now for number 33 and 34, it says factor each expression. So here we have, again, it's not written properly, but it means 2x cubed plus 12x squared minus 4x minus 24. Now, whenever you see a polynomial with 4 terms, it usually can be factored by groups of 2's. So let's see if this one would be what I said it would be. 2x cubed, let's group by 2. So we have 2x cubed. I'm going to group it with the 1 beside it, which is the 12x squared. So that's our first group of 2's. And then we're going to take the last group of 2's together. I always put plus. And then I have the negative 4x minus 24. That will be the second group of 2's. Now what do you do here? You look for the greatest common factor in each group. So from here we could factor out 2x squared, and then we'll be left with what? X plus 6. So that takes care of that. And you can check. This time this will give me back that. 2x squared times 6 will give me back that. How about the greatest common factor over here? Well, we could take out a negative 4. And when we do, we'll be left with an x plus 6. And you know you're on the right track when your parenthesis term here is the same as this one. And now you look at this as one term, this big cluster as one term, and look at this big cluster as another term. You say, what is common to this and this? And you can see what it is. It's x plus 6. X plus 6 is common to both. And from this one, what's left? 2x squared. And from this one, we'll be left with, from this whole term, left with minus 4. This is an interesting one because, let's see. Here we have x plus 6. I thought it was factorable again, actually. Let's see. It's almost factorable again. In fact, we could take out the greatest common factor of 2 from this and this term. And we could take it, let's take it all the way to the outside. We'll be left with x plus 6. Then, having taken out the greatest common factor of 2 from here and here and put it over here, we're left with x squared minus 2. So the three factors would be 2, x plus 6, and x squared minus 2. And you can actually, there's a special way of factoring this, but I haven't taught you that yet, so I won't touch it. Okay, and we get down to 39 and 40 now. Seems like I've skipped some in between, but I trust those are easy enough. 39 and 40 would say solve each polynomial equation by factoring. By factoring. Well, let's see. We have 2x cubed plus 3x squared minus 8x minus 12. This looks like we might be able to group again because we have 4 terms. 1, 2, 3, 4. So let's see how it would be if we group by 2's. 2x cubed plus 3x squared. I like to put plus here, and then that gives me the negative in here, 8x, and then a negative 12. That's equal to 0. We're solving it, so we want to find the x value that would make y 0. So grouping by 2's, did I do it? No, I didn't group here. I should group these by 2's. So what's common here? It's going to be x squared, right? What would be left would be 2x plus 3. And from this last term here, or this second group, what's common here and here? Well, it looks like 4 would be common. We could actually make it a negative 4. And then what would be left would be 2x plus 3. This is equal to 0. So we look here and we see 2x plus 3 here, 2x plus 3. It seems like we did it right. And again, like we just did before, we're going to look at this cluster and this cluster to find out what is common. And it's what? 2x plus 3, which is common. Okay, so I'm going to go over here and say 2x plus 3 is common. And that leaves me x squared minus 4. X squared from the left term, and then minus 4. But we can factor x squared minus 4 again. You say, how so? Well, you can factor it like that because it can be written like this. 4 can be written as 2 squared. So this is a difference of squares, and this is factorable as follows. A minus 2, not a minus 2, sorry, x minus 2 times x plus 2. And I trust you follow that. It's the difference of squares. And so one factor is this, another factor is this. So the complete answer would be as follows. 2x plus 3 would be one factor. The other two factors would be x minus 2 and x plus 2. And that's equal to 0. Almost forgot that. Since we're solving it, either this is equal to 0, this is equal to 0, or this is equal to 0. So these two would be pretty easy. For this to, well, if you're multiplying 3 things to get 0, then one of them must be 0. Either this one, or this one. For this to be 0, x would have to be what? Positive 2. That's for this one. How about this? What x value would make this 0? X would have to be negative 2. Okay, so that's another 0. And then finally, this one is going to be tougher. For this to be 0, 2x plus 3 to be 0, we have to subtract 3 from both sides. We have 2x equals negative 3. Divide both sides by 2, and we get x is equal to negative 3 over 2. So that would be the third 0. And you have 3 zeros whenever you have cube. If you have to the 4th, it would be 4 zeros. X to the 5th would give you 5 zeros. Okay? So that is as far as I think I can take it with what we've got here. I trust this will be helpful to you, and may God bless you as you diligently apply yourselves.